Without question, the PID block is the most important function block provided by a commercial process control system. Digital implementations provide numerous features and options. The most significant of these will be the subject of subsequent videos. This video presents a more detailed representation of the PID block. The objective is to introduce the control error and the operational modes. The representation of the PID block from a previous video only presented the inputs PV and set point, and the output M. Another important variable is the control error. The control error is the difference between the set point and the process variable. The control error E is the output of a comparator within the PID block. As normally drawn, the set point input is positive and the PV input is negative. Consequently, the control error E is SP minus PV. However, this is arbitrary, and as we shall see in the next video, the signs can be reversed. The representation of the PID block contains an internal block labeled modes. This block provides the control calculations. Sometimes control engineers use the label controller for this block. In the context of the PID block, the term modes is used in two very different contexts. For the block label modes, the context is control modes. Sometimes a PID controller is referred to as a three-mode controller, the control modes being proportional, integral, and derivative. As typically drawn, the control error E is the only input to the modes block. This suggests that all modes are computed from the control error E. This is the classical form of the PID, but in digital systems, the derivative mode is more frequently based on the PV, and occasionally the proportional mode is based on the PV. Both will be the subject of later videos. The term modes is also used in the context of operational modes. There are also three of these: manual, automatic or just auto, and remote. The representation of the PID block illustrates only the manual and auto modes. A two-position switch is located between the output of the block label modes and the output of the PID block. The output of the modes block is connected to an input labeled auto. The process operator specifies the value for the input labeled manual. When the switch is in the manual position, the process operator specifies the output of the PID block. The result of the PID control calculations is not used, and in practice, the control calculations are not executed when the mode is manual. When the switch is in the auto position, the output of the PID block is the result of the PID control calculations. The process operator is not allowed to specify a value for the output of the PID block when the mode is auto. The switch is not quite as simple as suggested. Transitions between manual and auto must also be smooth or bumpless. Initializing the control equation to achieve this is the subject of a subsequent video. The hot air temperature controller is in manual. Change the controller output to 87% open. This causes the hot air temperature, the cyan pin, to rise, eventually attaining 231 degrees Celsius. The hot air temperature set point, the red pin, remains at 210. This behavior occurs when a feature known as PV tracking is disabled. A detailed explanation of PV tracking is the subject of a subsequent video. Switch the hot air temperature controller to auto. The PV exceeds the value of the set point. So the PID control calculations decrease the opening of the fuel valve. The hot air temperature decreases, eventually attaining the set point of 210 degrees Celsius. When the mode of a PID block is other than manual, the controller output is determined by the PID calculations. Values for the controller output will not be accepted from the process operator. Before specifying a value for the controller output, the operator must switch to manual. The remote mode is only possible when an input known as the remote set point is configured. Its most common use is in cascade control configuration, and sometimes cascade is used in lieu of remote for the mode. Cascade control will not be presented in this series of videos, nor will the remote set point input be configured in any examples. The remote mode is beyond the scope of these videos and will not be discussed. The next video explains controller action.